Hi, this will be like a video manual and also a few patch examples for this thing. My switch module that I released 2 years ago, and I know that I should have done a video like this a lot earlier, but I haven't. So here we go. So this is a 4-channel bidirectional switch that can be CV controllable, and you can go in with the signal, any type of signal, on say on 1, and then come out on G for green or R for red, or you could go in here and out there and in there and out there. So you could have a signal coming in here and you can switch it to either of these two destinations, or you can have 2 signals coming in here on green and red, and then you can choose in between them and they can come out this way. And you choose by using the switch that can be latched so it stays, or you could use an external CV like for switch number 1. So you have a LFO coming in here, and that is switching in between the connection in between these two or these two. And that can be done up to high audio rate. And if you go high audio rate, it will switch cleanly way above 100 kilohertz. The layout of the front panel is such that if you would like to switch in, say, a stereo source, you can easily do that. So I position the switches this way for ergonomics, so you could easily switch the stereo channel in and drop it out like that. Very simple. Or momentarily, and so on. And I also thought it was a good idea to put all the connections down here, so it won't be in the way of your hands when you want to switch. A good way to show the basic function is that, say that I connect this yellow one. I will only use channel 1 because it's easy. The yellow one will be the yellow trace out on the scope. Green comes from the Doppler. It's a sine wave. And the red signal that you can see on the scope it's a sawtooth, also from the Doppler. And now this is green, so it follows the green. The output follows the green wave, and if I push this, it switches to the other one, like. And latching. And CV controlled. That's the basic stuff, sort of. So what if I would use, say, the green signal as the switching criteria as well? The thing is that when the input on the CV goes above 0.6, 0.7 volts something, then it switches. So what it's doing now is that whenever the green signal is above a little bit over 0, it switches over to the red signal. Or if I take the red signal and do the same, you get this. And if I turn on the latching thing, it will do it every second time, and you will get a subharmonic. And I stopped the oscilloscope so you can see here that it's switching every second time. Otherwise it's very hard to see. And then on these two signals from the same VCO, I've run them through my attenuator here. So by doing so, I can kind of massage the signal to have different shapes. Or if I stay with the concept of just using one VCO, so what if I would connect the pulse width modulation from the VCO and then use that as the switching criteria for the switch? Yeah. Then you see I can sort of scan from the sawtooth over to from the sawtooth and over to the sine wave by help of the pulse width modulation signal. And if I then connect, say, an LFO to control the pulse width modulation, you can get this. And subharmonic. Yeah, so you could sort of blend waves in that way, or if you use the triangle wave instead. And you could also do this at high audio rate if you want. If I, instead of having this one, I use another oscillator. So what I did here is that I disconnected the red signal, and then it will sort of switch on and off when the blue signal is above 0, which is here. So it's above 0 and it switches on or off rather. Okay, so what if what if it wasn't a synced oscillator? So if I use this sine wave out from the instru, and then we use one of the signals, for instance the green one, the Doppler, as a switching criteria. But you can hear that there's a lot of upper harmonics here, and that is because when it switches in between the two sine waves, it's doing this very steep step. So that way it's actually introducing upper harmonics like you've mixed in a square wave because of the steepness of the flanks. If you don't want it to be like that, you can do another trick. So I have prepared that by connecting the red and the green signal. So the sine wave from the instru oscillator and the Doppler one, the sine wave from the Doppler one, going into my zero module. And the zero module, if I connect that and then let that be the switching criteria, it will only switch when the waves are exactly equal. So if I stop this and we have a look at the wave, you can see that there are no steep flanks there. It's worst case upper harmonic adding thing you will get is these peaks here when it's going from one sine wave to the other one, and the shape of them are more like a triangle wave. So you will get upper harmonics added as if it was more like mixed in a triangle wave in this. And you could also do a subharmonic on this as well, and I think that's a pretty sweet sound. You can hear when I play the keyboard that these two oscillators are not tracking perfectly, so even if I would make this stop, they wouldn't. That's part of the fun with modular. Another way of thinking when you're mixing waveforms by switching in between them is that if you would just mix them, you would stack these waveforms on top of each other. And if you have two 5-volt signals and they would coincide in phase, you would have a 10-volt signal. But if you just switch in between them, you will never get a signal level that is higher than the highest level you have on the incoming CV signals. And that opens up also for some other creative uses. So there was some of the basics for the switch. There's a lot of more interesting patch things you can do with it, and I will do more short videos on that later, because I decided that instead of doing one mastodont super long video that tries to cover everything, I'll instead do shorter videos as I come up with patches. Could be more fun, I think, and it's easier to digest. So, thanks.